Hi guys, before we jump into the special signaling pathways of sensor systems, we first need to understand the basics of how G protein couple receptors and action potentials work. And in this first part of the video, we will be going over the general mechanisms of G protein couple receptors. And to get started, GPCRs have 7 transmembrane helices that crisscross the membrane, represented here in the green. GPCRs associate with G proteins, which include an alpha subunit, which is attached with the GDP, represented here. You have the alpha and the GDP. And you have a beta subunit and a gamma subunit. And together, these mediate most of our physiological processes. And in this class, we learned the process of the visual systems, which Markel and Sonia will go over, and the olfaction and taste system, which Sharu and I will go over. Now to begin with the general mechanism. In step 1, the ligand binds to the G protein couple receptor. And in this case, the ligand will be either an odorant or a tastant. But also, light can also bind to the receptor. Step 2, the GPCR exchanges GDP with GTP. Shown here, you have GTP leaving and GTP coming in. And now the alpha subunit, now with GTP, dissociates from the beta and the gamma subunit. And here is representing the activated alpha subunit. In step 3, the active alpha subunit stimulates the activity of adenylate cyclase. And the last step, adenylate cyclase catalyzes the conversion of ATP to cyclic AMP. And here I'm showing the overall reaction. You have ATP, which is catalyzed by adenylate cyclase, and that converts ATP into cyclic AMP. And now for an overview of what we just learned. In step 1, the ligand binds to the G protein couple receptor. The GPCR exchanges GDP with GTP. The alpha subunit dissociates from the beta and the gamma subunit. And now the active alpha subunit stimulates the activity of adenylate cyclase. And the last step, adenylate cyclase catalyzes the conversion of ATP to cyclic AMP. And that's pretty much it. And I hope this video has given you a general understanding of how GPCRs work. Now stay tuned for part 2 of the video. Now, for part 2 of the video, we will be going over action potentials. So an action potential, or a nerve impulse, is an electrical signal produced by the flow of ions across the plasma membrane of a neuron. And here I have drawn an action potential traveling down the axon, where it will eventually synapse with another neuron. And this whole process plays a central role in the cell-to-cell communication in the nervous system. Now, to help us understand how action potentials work, let's answer this question here. Draw out the membrane potential graph that depicts an action potential. Briefly describe the sequence of events that make up the graph and the direction of ion movement during these events. So before we answer this, let's first be sure to label the axes. And so in the x-axis, we're going to have time, which is measured in milliseconds. And in the y-axis, we have membrane potential, which is measured in millivolts. And so let's go on to step 1. The stimulus triggers the action potential. shown here. And so during the action potential, we're jumping to step 2. Sodium channels open, allowing sodium ions to rush into the cell. And this overall process is depolarizing the membrane, so it's making it more positive. So originally we start at a resting potential, which is at negative 60 millivolts. And so when you allow sodium ions in, it's making the cell more positive, going to about positive 30. And so this is where step 3 starts. So potassium channels then open as sodium channels close, allowing the membrane to repolarize as the potassium ions flow out. And so you have potassium ions flowing out of the cell, and so this is making it go more negative, to eventually you lead to a hyperpolarization, which is a lower membrane potential caused by the efflux of potassium ions and the closing of potassium channels. And so for the last step, the resting state, which is shown here, this is when the membrane potential returns to its resting voltage. So back where it was originally before the stimulus triggered the action potential. So hopefully now you know how action potentials work, mainly how cells become depolarized and repolarized. And that's it for this section. If you have any questions, feel free to email me.